minus sine square x dx. If you realize, we have cos square x and sine square x here. I know that previously we have learned and we have seen how to integrate cos square x, how to integrate sine square x. But do we need to use the exact same formula as example 3? No, we are not going to use that formula. Which formula am I referring to? This one, where we have sine square x is actually equals to 1 over 2 times 1 minus cos 2x, as well as cos square x is actually 1 over 2 multiplied by 1 plus cos 2x. Why are we not going to use this one? It's actually the same, but we have a much simpler formula. If you realize, this formula comes from the double angle formula. Okay, this is not a new thing. You have learned this formula in the first semester. So what is the double angle formula that we use here? We have cos 2x is equal to cos square x minus sine square x. So we are going to use this immediately, and what you are going to get is this question is actually equals to the integral of cos 2x dx. So you need to remember the double angle formula for you to be able to use that formula to ease yourself, to make your life easier in answering this question. So what do we get if we integrate cos 2x dx? This goes back to the one that we have learned. Integrate cos 2x dx will give you, integrate cos ax dx will give you sine ax divided by a plus c. So that is what we are going to get here. Sine 2x over 2, and we are going to plus c there. Why do I know my angle is 2x? Again, please remember, angle will remain the same. Okay, so let's take a look at question C. For question C, you are now asked to find the integral of 4 multiplied by sine squared 2x minus cos squared 2x. So, do we have any formula for that? No, we don't have any formula for sine squared 2x minus cos squared 2x. But again, we are going to use this exact same formula. But please take note that the symbol is a bit different. So what we need to do here is we need to factorize the negative sign. So I'm going to take out negative sign, negative, and 4 will be taken outside. So I'm left with integral of cos squared 2x minus sine squared 2x dx. And now since the angle is still the same for both cos square and sine square, you need to realize if the original formula just now is cos 2x is equal to cos square x minus sine square x, what happened if I change the formula to cos squared 2x minus sine squared 2x? Then the angle will also double here, which means I will have 2 times 2x, and that will become 4x. So the formula will change to cos 4x, and I will have negative 4 multiplied by the integral of cos 4x dx. And once you have finished that step, we can just integrate that, and that will give us negative 4 multiplied by sine 4x divided by 4. And then we are going to add c at the back. Negative 4 and 4 will cancel, and that leaves us with negative sine 4x plus c. Next, we are going to discuss example 6, where we need to integrate by using substitution method. So let's recall the substitution method that we have learned in chapter 5. For substitution method, you have to let u, and then after that you need to find du by dx. Then we are going to substitute into the question and then integrate. After we integrate, we are going to substitute u back, meaning you have to change from u to the original variable. So let's take a look at the first question. Question A, we need to integrate cos cube x. So we have not learned how to integrate cos to the power of 3. But since we have learned substitution method, we are going to use that method. Okay, how do we use substitution method in this question? You cannot directly choose, for example, u is equal to x or u is equal to cos cube x. What we are going to do first is you need to change this power into a mix of something added with something using the concept of indices. So I can practically rewrite the question as integral of cos square x times cos x dx. So what I usually teach the student is that the trigonometric function with power 1, that is the one that I need to eliminate, meaning I need to make that disappear. So how do I change that one? How do I make the one that I highlighted in blue disappear? We are going to use this one, cos square x. I'm going to change that into something else involving sine. Okay? Because I know cos square x can be changed using the identities. The first identity, which is sine square x plus cos square x is equal to 1. So if I need cos square x as a subject, then I can rewrite that as cos square x is equal to 1 minus sine square x. Okay, so from there, my question now can be I can rewrite my question as integral of 1 minus sine square x times cos x dx. Okay, so for this question, after we have changed using the identity formula, what we are going to do is we are going to choose which one we are going to let as u. So what we have here is 1 minus sine square x, and I'm going to take the one I highlighted in purple without the power as my u. So I'm going to use the green pen. Let u is equal to sine x. I'm going to take sine x only because I know I need to eliminate or I need to make cos x disappear. So how do I get cos x? I need to differentiate sine x. So u is equal to sine x. Then I will get du dx is cos x. And rearranging that, I'm going to have dx is equal to 1 over cos x du. After that, we are going to substitute back into the question. So now my question will become the integral of 1 minus u square multiplied by cos x and multiplied by dx. I'm going to change dx into 1 over cos x du. So again, we know without elimination, cos x over cos x, the value will become 1. So whatever I'm left with is integral of 1 minus u square du. So do we know how to integrate this? Yes. Integrating 1 with respect to u will give you u minus integrating u square will give you u cube over 3n plus c. Don't forget to substitute back your u. I chose u as sine x just now, so this one will become sine x minus sine x cube over 3 and plus c. And one thing that you have to do here is return back the power to the correct position. So we will have sine x minus sine cube x over 3 plus c. Okay, thank you.